we're going to be on section 1.1, and I'm going to call it day 1. All right, so 1-1, day 1. Now, the thing is, one other thing about this, you guys, is I write with my finger. Okay, I don't have a stylus that does very well, so I write with my finger. So if you can't read something, ask. Okay, because then I'll elaborate on it. But the first thing that we're going to talk about, and you guys should have had this a while ago, but it's probably been a while since you've done it. And what we're going to talk about at the beginning are what we call parent functions. Now, today we're going to talk about 4 different parent functions, but we're not going to be done with parent functions. We are going to have parent functions throughout the entire year. Okay? Some of these parent ones we're actually going to do a little bit more on. There's a whole chapter on one of them that we actually have today. So just so you guys know, these are not going to go away. Okay? The 4 parent ones that you guys are going to have today, the first one is called constant. Then you have linear. Quadratic. Oops, can't spell. And the last one's absolute value. So those are the 4 that we're going to work with. And to be honest, a lot of the first questions are going to be, which parent is this? So you're going to get like either a picture or you're going to get an equation, and it's going to ask you what type of parent is this. Okay, and then you're going to be asked, like, how do things transform? And we'll talk about that in a second. But what a constant is going to look like is it's going to look something like f of x or y equals, whichever way they have it. I'm going to look because I can't remember which one they have. They have y equals. It'll be y equals and then some number. And typically for the parent, it's the number 1. The graphs of parent functions are horizontal lines. Which way is horizontal? Is it up and down or left and right?
Left and right.
Left and right. Those are horizontal. Vertical is up and down. Okay? But anytime you have a constant function, you're going to have a graph that goes left to right. And I'm going to put that in blue just so that you can see what the graphs would look like. Well, I'll put the things in blue. And then I'll actually put the parent in red. So the parent would come right up here like this. That's what the graph would look like. Okay? So if they give you a picture of a straight line that goes left to right, that is a constant for the parent. Okay? As far as linear goes, linear is going to be y equals x. That's the parent function. Okay, y equals x would be the parent function. What it looks like is a diagonal line going through the middle. Does anybody remember what that middle one's called?
Origin.
Origin, right. Where the 2 blue lines cross each other, right in that middle is called the origin. So if your diagonal line goes through the origin, that is considered linear. Now, are both constant and linear straight lines? Yes. But one of them, the difference is, one of them is straight left and right, and the other one's got a slant to it. Does that make sense? Okay. Everybody okay with the difference between those two? The next one, quadratic. Y equals x squared. And the way these are going to look like, these are going to look like use. Have any of you ever seen or been to St. Louis and seen the arch? Or if I say the arch in St. Louis, do you know have you ever seen a picture of it? No? How about this? How many of you have driven down Broadway and have seen McDonald's? Like everybody. Some people might even work there. I did when I was in high school. Okay? If you take away one of the arches for the McDonald's sign and flip it over, that's the same shape. Okay? It's a parabola, is also what it's known as. For these particular things, just so you know, the quadratic, we'll actually have a whole nother chapter just on these because there's so much more that we can do with them. But for the first couple problems, you're just going to be asked to identify which one's which. So the main thing that I want you to look at is look at the equations as well. The constant just has a number. There's no x. Linear has an x. Quadratic has an x, but this has got a squared or an exponent. Okay, that's the difference so far between all of them. And the last one, absolute value. Y equals, and you have absolute value bars around the x. Now, a lot of times when people look at that, they ask if that's a 1 or something like that, but I try to make them a little bit bigger around the x so that they don't look like 1s in front of it. Okay? So for that particular thing, it's the absolute value bars that go around it. The picture for an absolute value does this. It makes a V shape. Okay. So as far as today goes, those are going to end on Monday when we finish off this section. These are going to be the 4 parents that we're going to refer to. Okay, so I'm going to ask you for, first of all, it's going to ask you identify the parent. So you got to identify which one of them it is. And then I'll ask you to sketch a graph of it, but then I'll also ask you to, from there, identify the different transformations. This is the second part that we got to get to. Okay, but these are the 4 that we're going to work with. Okay? Notice the difference between all of them. Again, constant is just a number. Linear is an x. Quadratic is x squared. So there's the difference between those two. An absolute value has absolute value bars around it. So if you see that, then you know it's one of those. Okay? Now, the next thing that I'm going to show you is something that I came up with a while ago. Okay? And it's kind of the basis for a lot of the things that we're going to do. And we do this in a lot of the chapters. We do this in probably like, I don't know, 6 to 8 of the chapters that we have. We have things called transformations. A transformation is changing it or shifting it or doing something different. I'm going to give you guys a template for this that I came up with probably about 4 years ago. And it doesn't change, and that way it puts everything in perspective as far as where things are at. Okay? I can apply any parent to this. So not only the 4 that I showed you, but later on we have other parents, and I can use this same template for those as well. Okay, so I'm trying to keep it simple for you. All right? So the way the template works is, first of all, you might have a negative sign in front of the whole thing. What a negative sign tells us is it tells us a reflection. Does anybody remember what a reflection is? Elijah?
Yeah.
What's a reflection?
It goes on the opposite side of the axis.
Yeah, you just flip it over. Right. In geometry, they refer to them a lot of times as a flip. Okay? So, for instance, this morning, did any of you guys use reflection by getting here? Some of you did while you drove. You should have been looking in your mirrors, right? That's safe driving. Or when you got ready this morning, did you look in the mirror or did you just wake up looking awesome? Okay? So for that particular thing, a reflection, if it's on the outside of a grouping symbol, that would be a reflection over the x-axis. So what that flips is that flips up and down. So instead of opening up, for instance, it would open down. It flips between up and down is what the negative does. Now, this next thing that I'm going to do is I'm going to put like what I call a little shadow box. And the reason why I call it a shadow box is because some of you guys are going to get these newer calculators, especially if you get the color screen ones. Okay? They have little shadow box things that you actually put the numbers into. Okay? So they actually look like this little dotted box. Okay? Like a dash box. What that means, if we have a number in that position, it means either a vertical stretch or a vertical shrink. Now, as you're writing that down, here's what that means. Think of something stretchy. Okay? Think of a rubber band in your mind. If I were to stretch it, what happens to the rubber band as I stretch? And vertically means up and down. If I stretch it, what would happen to it?
It would get thinner.
You get thinner, you get a little tighter. Okay? But that's what happens to graphs. When you stretch it this way, it goes thinner. What would happen if you shrunk it or pushed it together, squeezed it? It gets wider. And that's exactly what happens to our graphs. Okay, so with that number in that position, now the way it stretches is if that number is bigger than 1, and it shrinks as if that number is less than 1 but greater than 0. What types of numbers are less than 1 but greater than 0? Decimals, fractions. But be careful when you say decimals and fractions, because if you had something like 5.8, that's not a shrink, that'd be a stretch. Okay, so be careful with those. Then you could potentially have a grouping symbol. Now, grouping symbol could be in the form of parentheses, it could be in the form of absolute value, it could be in the form of square root. All those are possibilities. Okay? Then you could potentially have a negative sign in the inside. If it's a negative on the inside, it'd be a reflection over the y-axis. So instead of flipping something up and down, y-axis is going to go which direction then? Left and right. This way. Okay? So if you think about a parabola, like hopefully next weekend we see a lot of the refs do this at the football game on Friday for us, right? Touchdowns. That's a parabola motion. If we reflect it over the y-axis, a lot of times nothing changes because then it just stays in the same position. But if you were over a ways and you reflected it, it would go like over here. Okay, that's what a reflection over the y-axis does. Your McDonald's symbol is a reflection over the y-axis. Okay, that's what that is. Then you could potentially have a number on the inside. So again, all these shadow box looking things are numbers. It would be a number. And I know I hate drawing arrows, but I can't fit it any other way. I'm sorry, you guys. If it's on the inside, it'd be a horizontal stretch. If that number is between 0 and 1, or shrink if it's greater than 1. So what happened between vertical and horizontal? Anybody notice what I did differently?
You split it.
Yeah, because they have to be different from each other, because one's horizontal and one's vertical. They have to be different. So all I did was just flip the criteria. So instead of having a stretch be greater than 1, now a stretch is between 0 and 1. So that's what happened. And again, those are going to be numbers in those spots. So it's not like you're going to have to find them, or you're just going to have to tell me what number is in that spot is basically what's going to happen. Okay? Then you're going to have the letter X. You can forget about that meaning times. Okay? That does not mean the time sign. In algebra, X is a variable. We do not use it as a time sign. The only time you might see it as a time sign is when we're dealing with scientific notation now. But that's it. No other times, okay? So that does mean X, it does not mean times. And then you could potentially have a plus or a minus with a number. Now I put plus and minus like that because I don't know which one it's going to give you. It's going to give you one or the other, or none. If it's adding, that is a shift to the left. And if it's a minus, it's a shift to the right. And all that means is physically, if you shift something, like if I just went like this, I just went 2 units or 2 spaces to the left. 1, 2, I'm 2 units back to the right. Like that's what that does. Didn't change my size or my shape, but it changed where I'm at. And the last one, I know it seems like it's forever, but honestly, this little thing right here is going to be in probably about 7 chapters for you this year. There could potentially be one more number on the outside. Which direction do you think we haven't talked about? We've talked about reflecting it. We've talked about stretching and shrinking it. We talked about shifting it left and right. What's the only way we haven't gone? Up and down. Right. If it's a positive, it'll shift it up. And if it's a minus, it'll shift down. Now, to be quite honest with you, as you guys are writing that, just so that you guys know, in today's stuff, really, I give you everything. But all you're going to have to worry about is 2 of those. Okay, so it's not going to be one that has every single piece. They're not going to be that big. They're not going to have all 6 pieces have something in that spot. The most you're ever going to see is probably like 3 pieces might have some. Okay? Now, the questions will ask you to do this. And I better read it, otherwise I'll mess up the directions for you. Okay? But the directions will say, graph the function and its parent and describe the transformation. Now, when I looked at the big ideas problems, the describe the transformation was like a drag and drop. Okay, so it's like a fill in the blank type for you. Okay? As far as the transformations go, these are your answers. Like reflection the x-axis, vertical stretch or shrink, reflection the y-axis, horizontal, shift left, shift right, shift up, down. Those are the answers. You just have to tell me by how much. And that's because you'll have a number in that spot. So here's how the problem's going to look. And again, like I said, you're not going to have very many big ones like that have all of them. You're just going to have maybe 1 transformation or possibly 2. So that's the problem. The directions again say graph, function, and its parent. Okay, so here's the catch. How many graphs do you want to have on there if it says sketch the graph and its parent? How many should you have? You should have 2. Because you have the graph itself and its parent. It'd be kind of like you taking a picture with your parent or your mom or your dad, right? Yesterday, some of you probably did that on the front steps, I'm guessing, outside. Like, oh, we're entering 11th grade. Or last day of first day of school or something like that, right? Facebook. Okay? So you want to have 2 things on your graph. First thing I want you to tell me is, which parent is this? Is that constant? Is it just a number? Is it linear? Does it have an x? Is it quadratic? Does it have x squared? Or does it have absolute value where it's got the absolute value bars? What do you think? It's linear. Why?
Well, it has the X.
Yeah, it has the x. That's it. Like that is 100%, it's linear. Okay? So for me, I have my axes. And by the way, if you want graph paper, if you're one of those people that would like to have graph paper for anything, there's graph paper over in the bins and the trays. You just have to tell me if you take the last piece so we can make more copies. Okay. So the parent, according to what I gave you a little bit ago, the parent was this. Right? That's the parent. So how do I draw the new one? What are some of the ways you can draw pictures or draw graphs? Could you put numbers in for x to see numbers that come out? I sure can. What if I put 0 in for x? What's 0 minus 4? Negative 4. Which means this, you guys, and I'll put it in blue so you can see it. That means that if I put in 0, that's my x, and I'm getting out negative 4. That's the y. So it's like this. It's like me creating a table of values where 0 went in and I got negative 4 out. That's an ordered pair. You guys have been graphing ordered pairs for a long time. 0, 1, 2, 3, 4. Make dot. What if I put 1 in there? What's 1 minus 4? Negative 3. Here I am making a table of values. If I put 2 in there, what's 2 minus 4? Negative 2. Now what can I do with the 3 dots that I got? Connect them. Draw them. Now my goal is, I hope that you won't have to necessarily make a table of values for every single one of these as we get going. Maybe at first, just to get the hang of it. But for real, by the end of this stuff, I want you guys, we'll be able to get this without even having to do that. Now, here's how that template I gave you worked. Okay, here's how it works by, the second part of the problem is going to say, describe the transformation. Is there a negative sign in front of the x? No. Is there a number in front of the x? No. Is there a grouping symbol at all in this problem? No. Is there an add or subtract at the back end of it? Yes. What does a minus 4 tell you to do? It shifts down. How far? 4. That's describing the transformation. The transformation would be a shift down 4. Now think about the black line to the blue line that's up there. Is that what happened? Is this same shape? Like if I picked it up, have you ever worked with Word and you have a picture in there and you don't want it in the right spot and you grab it with the hand tool and you move it and drop it? Isn't that what happened? Grab this, move it down 4, drop it, and that's the same shape, isn't it? Or close to it. My graphs are by hand. They're not perfect. Oh, well, they're pretty close, but they're not perfect. Okay? This is what you're going to have to do. And you're going to have like at most 1, maybe 2 transformations, but really it's mainly 1. And the only 2 transformations that we're going to focus on for this one is shifting, left, right, up or down, or reflecting. That's the either going up or down or left or right. I'm not going to give you any stretches or shrinks today. I'll do that Monday. Okay? How much time we got? Are we 45? Okay. I can never remember. All right, I want you guys to try one. So, again, I'm going to put the directions in red so you guys know. Graph. And its parent. That'll be the first thing. And the second thing, describe transformation. One thing that I've kind of, as you guys are going through it, don't be afraid to ask each other too in your groups, because I'm going to ask you guys to tell whatever. But also, you guys, for me, a lot of times I might do the second thing before I do the first one. Maybe describing the transformation helps me graph the new one. So that's something to think about.
Well, actually, I'm not sure where it starts. Okay. So, which one is it? Well, absolute value. So we know it's this. Yeah. Okay. So now, as far as absolute value bars are concerned, so I said that there might be some sort of grouping symbol.
Well, we can go home and start this over.
That could signify group. No. What's a plus one?
All right, so first question, because as I got this question, where do I start? Well, the first thing I would say is, what parent is this? Absolute value. How'd you know? Because there's a symbol. Yes, exactly. That's a simple answer. Okay, and that's all it needs to be. And here's what I did, because me personally, I like to do the transformations first before I go to the graphing. Is there a negative on the outside of a grouping symbol? No. Is there a number on the outside of the grouping symbol? No. This, remember, is a grouping symbol. So that's like the parentheses in that template I gave you. Is there a negative in front of the X? Is there a number in front of the X? X. Is there a plus or minus on the inside? Yes. What's a plus 1 tell you on the inside? To go which direction? On the inside. We're going to go left 1. A negative on the inside, or a positive on the inside tells me to go to the left. Okay? Now here's how I use that to help me draw the picture. The original parent, the one that I gave you at the beginning, looks like the V right here. Now, you remember when I told you about the whole Word document as far as dragging it over? You told me to go left 1. If I grab this right here and go over left 1 and then drop it, shouldn't it look like the same thing just in a new position? Like this chair. If I dropped it or moved it over, did I change the shape or size? I just moved it to a new location. Same thing here. So if I move it over 1 space, it should look the same as the original one, just left 1 space. Okay, does that make sense how I did it? Now, that's not the only way that you can do that. In order to make those graphs, could you have plugged in numbers like 0, 1, 2, 3 and got a table of values? Would that have worked? Yeah, it would have. However you guys want to graph things, I'm giving you guys that option. Okay? How do you guys feel? We'll see. As far as the stuff, that's it. That's all we're doing today is just worried about that type of thing. Okay? So as far as what I got for you, I already have it on Google Classroom, but just so that in case you like to write it down, it's on page 8. It's 9, 10, 12, 13, 15 through 18.